I did not at any time had my CPU utilization more than 5%. So it means I earned 3 credits. Now, let's say I had 4 times. So what happens? I went for -3. Next, it is idle. Nothing happened. So 1 minus will get deducted from there. So the max I can go 72 in my particular account. And this is my limitation. So it means as soon as I reach 5% of overall CPU utilization, my 1 credit goes down. If I reach 10% based on this. So this is what it is, the concept is. Okay, then there is an asterisk, and then you need to understand it. How do you credit earn rate? So this is also based on this table. Actuarial limit is based on the table. Lifespan is like, so till the time your till the time your instance is running, it does not get expire. But for a higher configuration, T3 CPU credit balance 7 days, and then after that no credits are lost. So if you start the instance within 7, no credit. Okay, so the point is like if you have a stop date, it will be there for 7 days, and in between if you start it, your credits gets up, else it will be lost. For T2 does not mean start and stop, that it will be lost. Now there is a formula. What is the baseline utilization? The baseline utilization is the level at which the CPU can be utilized for a net credit balance of 0. When the number CPU credits being earned matches the number of CPU credit being used, baseline utilization, also known as the baseline. Baseline utilization is expressed as a percentage of virtual CPU utilization, which is calculated as follows. Number of credits earned by number of virtual CPUs into 60. Divided by 60 is equal to percent baseline utilization. For example, a T3 nano instance with 2 virtual CPUs earns 6 credits per hour, resulting in a baseline utilization of 5, which is calculated as follows: 6 by 2 into 60. Okay, so basically what happens, let me do some math here. So basically what it says, 6 by 2, which is like 3, then which is like 30, and into 100. Okay, so roughly it's 3.33, and they have rounded figure it to 5%. Okay, so here if I go for 96 by 4 into 60 into 100, so basically like 12 and 5, 8, 4, 2, 5, 40. Yes, we are right, correct. Unlimited mode. So there is an option for unlimited mode. So it says like when you are in unlimited mode, it can sustain high CPU utilization for any period of time when required. And the hourly instance price automatically covers all CPU users. And for naturally, this is going to be the costly one. And one has to calculate the price and then subscribe for it. So, okay, what is the unlimited? So the question is like, this is a good question. Maybe how unlimited burstable performance works. This is the AWS, this thing. Okay. So let's read, if a burstable performance instance configured as an unlimited depletes its CPU credit balance, it can spend surplus credit to burst beyond the baseline. When its CPU utilization falls below the baseline, it uses CPU credit that it earns to pay down the surplus credit that it spent earlier. Earn to pay down the surplus credit is spent. The ability to earn CPU credits to pay down surplus credits enables Amazon EC2 to average the CPU utilization of an instance over 24-hour period. If the average CPU uses over a 24-hour period exceeds the baseline, the instance is billed for additional users at a flat additional rate per virtual CPU hour. The following graph shows the CPU usage of T3.large. The baseline CPU utilization for T3.large is 30%. If the instance run at 30% CPU utilization or less, an average over a 24 period, there is no additional charge because the cost is already covered by the instance hourly price. If the instance runs at the 40% CPU utilization on average over a period of 24 hours, The instance is built for additional 10% at a flat additional. So what happens, like, in a 24 hours, and based on the machine you chose, there is a defined utilizations based on yeah, number of the credits you can earn and the virtual CPU. So and we saw the math, right? So your utilizations level is defined by based on your server name. Okay. Now in this 24 hours, you are into an unlimited spot and you went ahead. So the system calculates what was your overall average CPU utilization for 24 hours. So for example, you have a spike of 90% and then you don't have a spike in another hour for like 10%, so your average is like 90 10 by 100, so it's like 50%. So same way, if they see based on the server name your CPU utilization is within a baseline or up to the baseline, there is no extra money because you are being charged on the hourly rate. But if they see that it's a 40% or a 50%, they will charge you for the additional 20% rate per virtual CPU hour. So if it is a 4, they'll charge you 4 time into 10, 4 time based on the number of CPU and how many hours. Okay. So what does it mean? Like if it's 10%, so you have in one day you have a 24 hours, so you will be charged 10% for 10% for another 24 hours into number of the virtual CPUs. Okay. So there is an when to use unlimited mode versus fixed CPU. This is also a good question. When to use unlimited mode versus fixed CPU. So I'm also noting down, as I go down, for another video down the line for interview question and answers, and there I can, come back and discuss. So there is a two things they say. The average CPU usage over a 24-hour period is at or below the breakdown CPU. Use a burstable performance instance. And if your average CPU is above the breakdown CPU uses, and then it will cost you more. But let's see, does it says, okay. So basically you have to, calculate it, and I would say, and then take a decide, and it can only become with, load time, but it depends. Let's say I have a mobile app and somebody let's playing a game and there are so many users and so I have to do those analysis, and I think it will become difficult at the initial time. If I have my fixed workload, at least a person can make a decision based on all those mathematical calculation, but if my demand keeps up and down, those needs to be analyzed. Okay. So I think it says you need to enable the unlimited mode, and since it comes with the costing, so it will not be go with the default. And so once you choose these instances, you happen to see it. Okay. Then this is the thing. I mean, like if you have understood the basic thing, it's fine. If not, then one can go this thing. So the basic concept remain the same. They are explaining with the different scenarios. You do not have to, you just like need to understand it, how it works. That's it. So it is more for the people who are, I would say the more for the people who would, yeah. So not, I would like just to got to know if you know the basic funda fine, and then it's pure math, simple. Okay. And this is there are some other things what it says, like standard mode concept, how this thing work. Okay, standard mode examples. And then this, I think this is like something. Let's go with the concept. So it says like if I wanted to enable standard mode, it can be done without stopping or or at a running time. And then say how standard bus table performance instance work. And this is a good question, somebody can ask you. So just let me note down how standard bus table performance works. So let's read, when a bus table performance instance configured as standard is in a running stage, it continuously earns a set rate of earned credits per hour. For T2 standard, when the instance is stopped, it loses all its accrued credits and its credit balance is reset to zero. When it is restarted, it receives a new set of launch credits and begin to accrue earned credits. For T3 and T3A, the CPU credit balance persists for 7 days, and after the instance stops, and credits are lost thereafter. If you start the instance within 7, no credits are lost. A T2 standard instance receives two types of credit: earned credits and launch credit. Okay, so there's another question. What are the two types of credits? Which is earned credit and launch credit. Earned credit and launch credit. Okay. So when a T2 standard instance is running state, it continuously earns at a millisecond level set earned per hour. At the start, it has not yet earned credit for a good startup experience. They have to provide a good startup. It receives launch credit start when spend the first while it acquired this earned credit. Okay. So basically, I thought it will be explaining some technical aspects, how the coding has been done. But the thing is, like they say, like if you are into T3, T3A, the thing is, like if you stop it and if you restart within a 7 days, your credits are not lost. But if you are on a T2 and you stop it, your credit goes zero. Okay. So launch credit, so this is the by default launch credit. So basically what happens, like, since it is a stop, so system automatically gives you the launch credit, and it is being used, and then you get another credit limit. Okay. So let's go to the example. So the same thing, maths, you need to understand, and you can have a time to read it. And so how do you do it? So you have to go to the console and choose the instance type, and then follow this document. You can do AWS CLI. Basically, when you go to the configure instance detail, and then you can have this thing. You can also, okay, you can have an auto scaling group to launch as unlimited. So you can set it up, and when this is launch auto scaling, it will automatically enable it. And just you have to follow the consoles and go to the create auto scaling groups. You can remember, what you need to remember from the interview perspective, like, how do you do that? You have to go to the auto scaling group, and then you can just work on it. So you cannot remember these things, but yes, it is just a side note. How do you monitor your CPU credit? Okay. So okay, so in the CloudWatch metrics, these values are updated every 5 minutes. So this is an important question. I would say, like, you can just have a note. How do you monitor your CPU credits? So how do you monitor CPU credits? So basically, you need to go to the CloudWatch, and in that it is updated every 5 minutes. So, and this happened for T3, T3A, and T2. And then there is a value, CPU credit usage, balance, and all, and then these are self-explanatory, this thing. And you have, okay, so this is a simple mathematic formula, that you have a CPU credit balance, and then whatever the prior you have it, and then based on 5 by 60, and then minus whatever you've used it. So yeah, it's a simple one, no need to remember. Okay. Then you have a compute optimized instances, which falls into C5 and C5N. So I think N is for Nitro, but C5 is yeah. So it is for batch, media, high performance computing, scientific modeling, dedicated gaming server, machine learning. Then you have a C6 and C6 for high performance computing. So the question could become, uh, what is HPC, high performance computing. Then you have a batch processing, ad serving, video encoding. And as you know, like as I'm reading it, if you visualize it, these are especially very, compute intensive. And then you have, so basically the thing is like, let's say you're doing a solutioning for these industries, scientific modeling and all. You come here and you see, okay, these are the available hardwares, and you do your further calculations, and then you check the network performance from the existing bandwidth, or do some further analysis, like that if there is a scientific modeling, where are the two teams are sitting, for an example, how much data you need to transfer across those teams, what is the size of the file, what is the pipeline set between these tools, and and how much they need, and you have to understand like how the traffic goes from one client server to this, and in between you have an AWS, and then you see these things, SSD performance. So basically what you have to do, you have to do the performance baseline for the existing environment, and then come to this page, see, okay, you just fall to this area, and then you decide, you know, which server is used to do the calculations and do it. Now you go to the memory optimize. So for memory optimize, the instances are R5, R5A, R5N, and these are for high performance relational, MySQL, NoSQL, distributed Bayes scale, in-memory databases, application real, this thing, elastic design automation. So what happens with the memory optimize? The memory optimize is like, what happens if you see about these applications. So these applications are, the backend of any infra which we access. So these are not the front end, and so internally at the database level, they if I run a query, SQL query for an example, it goes into the system. The data will be at the very t is equal to 0. First time you do it, it will be always on the disk, and it will get passed. And if it is frequently being accessed, it will be put into the memory, and in there, if and it will remain in the memory based on the frequency of access. And once it is at the memory, then you yeah, so then what happens that yes, so it is like, it is in the memory, and then it is a memory intensive in a sense, like, because if it does not reside in the memory, that the way that these databases are designed, there will be lot of physical IO, and this will deteriorate the performance of data retrieval. Okay, then so if you, I think it's like a more towards the backend databases, SAP, HANA, Apache, and EDA design, hardware. So the same analysis you do, network and this. So the thing is, once you put in an Excel sheet and you do this, you will get an actual picture with the cost and all, and then you can provide the best combination. Then you have a storage optimized, which is like a data warehouse, Hadoop, login data processing. Then there are, these types of libraries. These are storage optimized, high frequency OLTP system, relational database, NoSQL, cache, and then you do the same set of analysis, put into the details in Excel sheet, do the math, and get with the good combination of good combinations of the hardware for your configuration. Then you have an accelerated uh, this thing. This is generally for graphics. Graphics, yes, graphic based application. So you have an F1, Infi1, P3, P2, Z4. You do the same set of calculations, do your math, put the cost, and get into Excel and get the this thing. Then it says installing NVIDIA server. So what happens, like an instance with an attached GPU such as P3 and a G4, which is for gaming and processing, needs to have a NVIDIA driver installed. You can either download the NVIDIA driver. So basically, like, you have the hardware already, but you still need to get your own driver. That's what I understand. And then there are three types, which is like Tesla, Grid, and Gaming. And for example, if you are interviewing for a solution architect in the gaming industry, you need to know this. If you say you don't know, so they will know, hey, you don't know, right? So, and then you do your calculations, and you have to follow the same process as it is. It's not like, and you have to go the same way. And I would suggest always check the latest document, check the OS version, do this thing and start it. And then you have to follow this thing when you, how do you enable it? And there is a way how want you optimize the GPU settings, and definitely uh, there is an option for graphical, to achieve the better performance. And you have to, it uses an auto boost feature which has a varies GPU clock speed, and then it says if you disable this feature and setting the clock to maximum, you can confidently achieve the maximum performance for your GPU instance. Next is like a FPGA. What is FPGA? The FPGA developer provide the tool for testing building AFI. So I think preferably this is some, field programmable gate array. Okay, so this is I think this falls into high performance computing, and this is for some specific requirement. And if you are falling into this, you need to follow this part. Okay. So again, it comes from Infintia development. This is for accelerating the machine learning using AWS Infintia, which is a custom AI/ML chip from Amazon that provides high performance and low latency machine learning inference. So these are optimized for deep learning models, natural language, and then there is a variety of these applications. Amazon SageMaker, and you need to use it. And then how do you do it? You have to, go here as a console, and that's what I was saying. Like, you have to calculate all those things, put in an Excel sheet. Storage, you have to see existing pricing, networking, memory, put it in Excel sheet, and then you can do it. So how do you go it? So the best is the console. And when something new are touching up, go to the console. It will give you additional 10,000 informations. You can see it. You can correlate it. But in this thing, this is like for more advanced users. Apart for administering, if you are doing something like this, I would say go to the GUI console. Okay. So the thing is, like, as you go move ahead, you need to change the instance type. Okay. And so you have to, do further analysis. What is the virtualization type further required? What is the architecture, network, and enhance NVM, AMI, and basically what happens, like, this plays an important part architecture. So kernel parameter, OS version, you have to see whether your hardware is compatible or whether your app is compatible with the existing application, if it is a vendor supplied applications and all those things. And then you have to resize the storage, and then there is an option how to do it, and then you have to do the migration. So and then there is a different way to migrate it. And so basically it's like a rehosting thing which we have done in our career most of the time. It's just like an AWS way that we here, if you are a solution architect providing a consulting, you need to provide most of the things. So in a typical setup, there will be a PMO or there will be a PM team. They will have an Excel sheet. They will connect all the database, front end developer, app developer, and all those things. And then they will talk and they will amalgate it. But here, this will not work out. So here what happens, like, you need to uh, you know you need to do this yourself. So how do you get a recommendation? So okay, so there is an AWS Compute Optimizer provides Amazon EC2 instance recommender to help you improve, save money, or both. You can use, whether to move to main computer. So there is a utility Compute Optimizer, and there is a guide how to do it. So I was just saying my way, what you do, and I do it. But you can also do this. Okay, and it will take certain inputs, and then it will generate the results under provisioned, over provisioned, optimized. Nothing is required. It will just ask you some key matrices, and yeah, and this is the way. How do you do it? Open a console at this. So basically, console and computer manage will get you to that console, and then from there, and you again evaluate it. Okay. So this could be another basic questions. What are the purchasing options for the instance type? What are the purchasing option for instance type? Okay. So you have an on-demand where you pay by the second. For that, you launch your saving plans where you enroll for 1 to 3 hours. Then you have a reserve instance for a term of 1 to 3 hours. Then you have a schedule instance that are always available on the specified running schedule. Then you have a spot instance which requests unused. Then you have a dedicated host. Then you have a dedicated instances. Then you have a capacity reservation. So yeah, then you can. So the life cycle of instance is when it is start and when it is terminated. To determine the instance life cycle, you can go or either you can have this thing. Okay. So I think let's stop the recording here and I meet you again in the next video. So let's have some break. So see you again. Yeah. Thank you.